This is question 4 of 4 of the questions that a student emailed me. Not going to say who. And this question just reads, probability that exactly 3 people out of a group of 35 have the same birthday. So they want us to find this probability. All right, just by reading the question, you can tell that it's a counting question, like a permutations or combinations, a question using counting techniques. So we are going to need this formula over here. And like I always say, we should find the total number of outcomes before looking for the number of outcomes for the question, like this question in particular. All right, so I'm not gonna draw this, at least not all of it, because we have like 35 people, but I'll draw some of it. So we're gonna have person 1, person 2, person 3, all the way up to person 35. Person 1 has 365 days of the year that they're allowed to be born in. And because we're allowing people to be born on the same day, the same applies for person 2. The same applies for person 3. The same applies for person 4, 5, 6, and so on, all the way to person 35. So our total number of outcomes is going to be 356 or 365 to the power of 35. That's going to be our denominator, the total number of outcomes. Okay, nice. Now we have to consider our event. So our event is for exactly 3 people out of a group of 35 to have the same birthday. So first thing we're going to do is we're going to pick one day for those 3 people to have their birthdays on. How many choices do we get for person like 1, 2, and 3? How many choices do we get? We get 356. There's 65. We get 365 for our first person. First 3 people. Then we need to pick different days for all 32 remaining people, like all the other 32 people. I guess for all 32 people remaining. So in other words, person 4, whatever day they pick, they can't pick the same day as person 1, 2, and 3. So for them, they have 364 days. And that is just every day of the year, except the one day that these 3 guys have their birthday. So that's the choices for person 4. And then for person 5, we're going to have the same thing, except now it's 363. Because for person 5, they get to pick any day of the year except the one day that person 4 has their birthday and the one day that people 1, 2, and 3 have their birthday. So they can pick any day of the year except for 2, like person 4's birthday and person 1, 2, and 3's birthdays. And we keep going. So for person 6, it's the same story. This guy can pick any day of the year as long as it doesn't fall on the same day as the people here, the person here, and the person here. And we just trying to keep this up. So I'm not going to draw right out all of them, but for person 35, we need to figure out how many days they are allowed to pick. So you're going to notice a pattern. For people 1, 2, and 3, they get all days of the year. But for person 4, they get 365 minus 1. For person 5, they get 365 minus 2. And then for person 6, they get 365 minus 3. So you can start to see a pattern between this minus 1 and the 4, between the minus 2 and the 5, and I'm drawing the arrows in the wrong way, sorry. Between the 4 and the -1, between the 5 and the -2, and between the 6 and the -3. And the pattern here is subtract 1. Like if I subtract, subtract 3. So if I subtract 3 from 4, I get the 1, the -1 over here. And it's the same story if I subtract, hold the phone. If I subtract, for example, 5 from 3. If I subtract, 3 from 5. If I subtract 3 from 5, then I get that -2. And lastly, if I subtract 3 from 6, I get that -3 over there. Keep forgetting to change these. But what I'm saying is, like, whatever number we have in the bottom here, we just take that number, subtract it from 3, and we subtract that difference from 365. That's how we know what number to write over here. So let's go do that. And I think I've just made a mess, but let me try my best to clean some of this up. I'm just gonna try my best. All right, so again, we're just gonna subtract 3. And then subtract whatever difference we have from 365. So I'm gonna take my 35. 35 minus 3 is 32. So I take 365 minus 32. That gives me 333. Dang, okay. So with all of these numbers, we just multiply them together because these aren't like, I guess, mutually exclusive events. They can happen at the same time. And that's going to be our numerator. Like this product from 365 to 333, that's going to be our numerator, and then our denominator is this right here. So we have a few ways of writing this entire probability. We can write it like this: 365 to the power of 35, and then we have 365 times 364 times 363 times ... times 333. How do you evaluate this with a calculator without like writing out all of these numbers? Well, you make use of a convenient way to write it. And that way is to do this: 365 to the power of 35. This, the numerator, just becomes 365 p 33. Yeah, 33. Because this is 33. Because the numerator is then 365 factorial divided by 333 factorial. Wait, did I leave out one? No, 32. Not 33, 32, sorry. 32 factorial. And this, like if you simplify it, it will work out to be that right there. So yeah, that is like, you would enter this into your calculator and then you'd be good.